welcome to SMTConnect 2023 in Nuremberg. It's day 2. First interview of the day, I'm joined by Eyal, who we spoke to yesterday actually.
Yeah, we did.
And you've got a lot to talk about.
Yeah.
So, traceability, surgical traceability.
Yeah. We're kind of introducing a new concept, which is exploratory traceability, which gives you the ability to do surgical recalls. I'll explain. The world today, the electronics world today, handles all the material by batches. This is how it works, right? If you have any case, you always separate it to the batch level. So if there's something wrong, and you have a traceability capability, then you can trace back all your material to the level of a batch. That's how it works. The batch could be 5,000, 20,000, 100,000 boards, depending on how you keep the batches, basically. Some people keep batches in the level of a packaging unit or for real, some in date code or lot code. So this is basically the extent of a recall or how you can manage your material, the quality of your material. Materials are handled by the batches today. This is just the resolution that you can handle because this is the technology that was available until now. Batches could be how you manage your material. It could be 5,000, 10,000, 100,000 boards. Really depending on your resolution of your information. The best technology today is to keep it by the reel. So it could be a batch size, could be the number of components inside a reel.
Right.
Or in most cases it's managed by date codes or lot codes, which can be much higher numbers. But it doesn't have to be like this anymore. We are in the age of AI and big data. So there's no need to handle material in a batch. Well, you can, but there's a new capability that allows you to address every individual component as an individual. Now, how do you do that? Because the packages are in packages, so how do you address them? Well, we address them by identifying with a picture. The same way you identify a person, right? So if this is you as a person, I can identify you by your picture. The same way I can do with a component. So we need a picture of every component. So how do we do that? We're a software company, so we don't have hardware. So what we're doing is we're using the images taken by the pick and place machines and the AOI machines as a part of the regular process anyway. So the pick and place machine, for example, is for every component that is picking up and placing on a board, there's a picture taken from the bottom side for accurate alignment. So we're using those images to identify the component. So from the bottom side, within the pick and place machine, we have the bottom side image, which allows us to authenticate it if it's a counterfeit or not, to find defects, to find corrosion, cracks, shorts. We can characterize all its properties based on its image from the bottom side. Now, as the component goes to the AOI machine, the board goes to the AOI machine, we have a picture from the top side. And from the top side, we can read the marking of this individual component. Yeah. So, for example, we can read the lot code on the marking. So you don't have to trust the lot information that you get from the setup, which assumes that everything is the same, but you can read the individual component. So think about it. Every component going on every board, you have bottom side image, top side image, all the analytical data that we accumulated, the quality, the authenticity, the source, the manufacturer, the lot code, the date code, and so on. And everything is stored for every board. So this kind of traceability allows you to have individual component level traceability.
Yeah. And you'll know exactly which boards are affected by it, so they can be pulled out.
So think about it. Now, it can go two ways. As a failure analysis tool, for example, think about it. You have a failure analysis. Today, you're basically blind because you don't know the material that was used before. You only know the part number and maybe the lot code. Yeah. Now you have information. You're not blind anymore. Think about it. You have a system installed, an antenna on Switzerland on a boat. Okay, you cannot get it failed, and you cannot get the system back. It's kind of difficult. Yeah. But you have in your database all the conditions of all the components that were used on this specific place. Yeah. So you can find faults, you can find root cause analysis. You don't have to address them to return the entire batch.
Yeah.
This is one aspect. The other aspect is about recall. Recall is a huge pain in the electronic industry. If you have a recall, you are in serious trouble.
Yeah.
Nobody likes it. It could be a multi-million-dollar pain. But why is a recall happening? It's happening because you have to return the entire batch. Now, if you address the components individually, you don't have to return the entire batch.
Yeah.
You can do what we call a surgical recall. You can return only the faulty ones, only the ones with the issue. I'll give you an example. We had in one of our customers, we had a batch of 20,000 faulty components with mold that caused a high rate of failure that was caught in the ICT. So the ICT started the process, the quality started process of doing an internal recall to rework the entire 20,000 boards.
Yeah.
But when we went to their system and we showed them that there were only 700 that were actually contaminated with the mold. Yeah. So instead of reworking 20,000 board, they only did 700, which is a huge difference.
It's a win-win, isn't it? It's cost effective, and it's far better for sustainability and
of course the board. I'll give you a really cool example. Since we are now in Europe, sustainability is very, very important. We just published a paper about this subject. We had a case of a reel with 10,000 resistors. It was a 0402 resistors that was contaminated with corrosion. Now, we did an MTBF estimation of what the effect will be. So we calculated that this will reduce the life of the MTBF, or the life of the product, by about 25%. So this goes into a laptop, for example. Instead of living 4 years, it will only live 3. We calculated the effect it has on CO2 emission and our e-waste production, and it was from one reel a damage of, I don't remember exactly the numbers, but it was about 20 tons of CO2 emissions and many kilograms of e-waste just because of one faulty reel. So the impact of controlling the material can also have a huge impact on the environment.
Yeah. And it's looking at it in a holistic manner like that you realize the benefits of it, rather than just specifically, it saved money on that issue.
And it's actually, it's much less expensive than doing any traceability, because you don't need any hardware. Yeah. All the hardware is already there. It's just a matter of software and processing the data. The data is stored very lightly in the cloud, so it's not too much data to handle.
Yeah.
And everything is handled by AWS or the cloud, so it's really easy and cheap, and you can very safe to use. And people come to us who don't have any traceability, saying, okay, this is going to be an expensive thing, but in fact, because you don't need anything, any hardware, any change in the process, any delays, nothing. It's just a question of installing a software and that's it.
Yeah. And cloud storage has enabled an awful lot, isn't it? Because that's been, it's a huge amount of data, isn't it?
This is all because made possible because of AI and big data. Yeah. Just a few years ago, when we were starting with this, we were talking to people. They told us that it's impossible. Yeah. That hundreds of millions of types of components. But today it's possible. People are also saying, what can you do with AI, ChatGPT, stuff like that? Well, you have to find the right application that really makes sense.
Yeah, which is fantastic. Well, thank you for the insight, Eyal. Good to see you again. Hope the show, I'm sure you'll have a lot of interest around the show with that. And it being that new is quite exciting. So thanks for talking to us.
Thank you very much.
Thank you.
Great being here again.